So now that you've finished the main content of the course, you know all of the basics to FMOD and its API. You can take a Unity game, integrate FMOD, and start adding multiple different events, sounds, music tracks, and more to it. But now it's time to dive deeper into FMOD's API with this brand new module as we take a look at more tools from within FMOD and its API that give us more control over how our player hears our audio. We'll be starting off this new module by going back over some of our previous scripts that we used to set values to parameters with. We'll then be examining them and looking at other functions that FMOD provides us with to set values to our parameters with. Before we start, all of the new commands, functions, and methods we talk about in this lesson were introduced with FMOD version 2.0 and will not work for any older versions. Now, if you'd like to update your FMOD and Unity integration package so that it works with FMOD 2.0, you'll be able to find a video underneath this lesson showing you exactly how to do that. So as well as this, I'd like to clarify some terminology before we move forward. Up until now, I've referred to a lot of lines of code that we've looked at as commands, especially when it comes to code from within FMOD's API. Now, a lot of these commands were actually functions or variables that had been declared from within different scripts or classes. For example, play one shot is actually a function that was declared within the runtime manager class. Now, whenever we use play one shot in our scripts, we're essentially telling a function that has been declared within the runtime manager class to trigger, which in turn runs all of the lines of code that were written within that function. Remember that the term declaring a function refers to where the function was first written in code, and the specifics about how the function will work are set, such as by writing its name for the first time, writing the function as void, or adding parameter variables inside the brackets next to its name. For example, this is code from inside the runtime manager class, and here is where the play one shot attached function has been declared. If we now take a look back at our f_staff take trigger class, we can see us triggering the same play one shot attached function. The reason why I've been referring to them by a different term was to simply differentiate them temporarily. Because triggering a function from another class looks visually different from declaring one inside our own class, it can be a little bit confusing at first to refer to them as the same thing. But going forward from now on, whenever we use a function from another script, we will refer to it as such. So throughout this course, we've been setting values to our parameters using the same function. And that function is, of course, setParameterByName. Now, setParameterByName is great because with one line of code, you can quickly and easily start setting values to parameters attached to event instances. However, there is an alternative method we can use in its place, and it's called setParameterById. Now, whenever we create a new parameter in FMOD, that parameter is assigned an ID, a code made up of two collections of numerals labeled data1 and data2 respectively. Now, in the same way we use the names of our parameters, we can point our scripts to parameters by feeding them this ID code using setParameterById. So when would you use setById over setByName? Well, setById is usually used when a parameter's value needs to be set multiple times within a scene or a level. Now, this is because it is quicker for Unity when searching for the parameter we're looking for to compare collections of integers with each other rather than collections of characters or string data together. So by using a faster command, we're improving the efficiency of our scripts. Now, on the other hand, for us to be able to find our parameter's ID, it does require us to declare a few more variables than we would have to when using setByName, which you'll see soon. Because of this, it is sometimes easier to just use setByName if you only need to set the parameter's value a few times, making testing your audio a lot quicker and simpler too. So in the case of our game, let's take a quick look at a couple of our old scripts and decide whether or not we need to use setByName or setById. Now, the first time we used setByName was for the teleporter at the end of scene 1. Now, remember how the event for the teleporter started with a loop, but played a one shot after we set our trigger parameter from 0 to 1. Now, because we only need to set the value of this parameter once during the entire scene, set by name actually works quite nicely here, and there's no need for us to replace it. However, one event that needs a parameter set multiple times during the scene is the ln run event and the material parameter within it. So let's quickly remind ourselves how the script we created to play the ln run event works. Now, the bulk of this script relies on the play run event function, which is here. Now, whenever this function is triggered, our script will check the surface our player is standing on, and depending on the surface, a value will be stored inside the material value variable representing it. Once it has a material, it will create a new event instance variable and store an instance of our ln run event inside of it and attach that instance to the ln game object. It then uses set parameter by name and sets the value of the event's material parameter to match our material value variable. Finally, it then tells the event to start to play and then releases the instance once the event has finished playing. Now, the play run event function is triggered by the animation of our player running. Whenever a step is taken during that animation, the path of our ln run event is fed into our play run event function, and everything we just looked at is then triggered, including the setting of the material parameter. So needless to say that Unity is having to compare the string of our parameter's name to the list of parameters stored within our sound banks a lot of times during gameplay, when it could be comparing an integer instead, saving time. So let's look at how we can replace set by name with set by ID to make this script a little bit more efficient. Let's start by changing the function from set by name to set by ID. Now, obviously, this gives us an error, which you can see here. And this is because for this function to work, it requires data in the form of the parameter ID data type, and not the name of our parameter as string data. So the first thing we're going to need is our parameter's ID. To do that, we'll need the help of a few new variable types that FMOD's API provides for us. So at the top of our script, we're going to create a new event description variable by writing private fmod.studio.event description and then giving it a name such as event des for short. Now, an event description variable is a struct that works in a similar way to an event instance variable. Both store information about one of our FMOD events, but the difference is where an event instance variable stores a reference to a single instance or copy of one of our events, an event description variable stores a reference to the entire event itself. Event description is usually used for accessing information about an event through your script, instead of getting your event to play or stop during runtime like you would use an event instance variable for. For example, with the event description variable, we can use a function called getInstanceCount, and as you can see in this image, this will return us with the number of instances that we've actually created for the event referenced inside the variable, which is very helpful when trying to manage your instances and making sure too many haven't been called unnecessarily. Now, you can find a link to the full list of functions you can use with the event description variable underneath this lesson, but in our case, we want to use it to retrieve data about our parameter and store that data inside its own variable. First, we need to retrieve the event using the material parameter to store inside of our event description variable. Now, we're going to do that on the first frame of our scene, so we're going to need to create ourselves a start function. Next, let's write the name of our event description variable and follow it with equals fmod unity dot runtime manager dot get event description followed by 2 brackets and a semicolon. Now, the get event description function works in the same way that the create instance function works for the event instance variable, except this time we're not creating a single instance of the event, but we're referencing the event as a whole. So just like the create instance function, we need to feed the path of the event we're after into the brackets of the get event description function. Now, the way we're going to do that is by creating a new private string variable, call it event path, and set it to our event path, which is event : / sound effects, ln, and ln run, and then feed that variable into our getEventDescription function. Now, if you'll remember back to the attaching audio to animations lesson in Module 2, you'll know that we fed the same event path into our run event instance variable that we declared inside the play run event function. Well, at the time, that made sense because the only variable that needed that event path was the run variable, which was declared within that function. However, now we need the same path for our event des variable. So it makes little sense to be feeding the same data into two separate variables. Now we could send the event path into the event des variable from the play run event function. However, we need that data on the first frame, which will be before this function is called. So it makes sense for us to then remove the event path variable from inside the parameter brackets of the play run event function, which I'm going to do now, and then replace it with a new variable declared within the class for both functions to use, which is what we've done. We'll also need to remove the event path from the animation event we created to trigger the play run event function, as it is no longer needed here. So what I'm going to do is come up to the string section, remove the event path, and then hit apply. I'm also going to select the other event marker we created to trigger this function and do the same thing just to make sure it doesn't trigger on either of the footsteps. Now, in case you've forgotten, you can find this animation in your project tab. Just choose Assets, 3D Game Kit, Art, Animations, Animation Clips, Characters, and then Ellen, and then look for the Ellen Run Forward animation. From there, select it and make sure you select Ellen Run Forward Clip. Scroll down the Inspector tab and you can find your event markers here. Okay, so now we have an event description variable with a reference to our Ellen Run event. Now it's time to introduce ourselves to another new variable type from FMOD's API. So at the top of our script, we are going to declare and fmod.studio.parameter underscore description variable, and we're going to call it param des for short. Now the parameter description variable has a similar purpose to the event description variable. Once we tell it which parameter we're interested in, we'll then be able to access information about that parameter for us to use in our code, such as its ID. Now let's quickly hold Command if you're on a Mac or Control if you're on a PC and click on the parameter description data type to take a look at the information we can access from it. Now, as you can see, parameter description is another struct that this time contains variables which will hold information about the parameter we choose to reference. Now, unlike event description, parameter description doesn't contain any specific functions within it for us to use. So to store a reference to a parameter into it, we'll need to use another function from event description. So inside the start function, we're going to write event des.get parameter description by name, and then inside its parameter brackets, it will need two arguments. Now first, it needs the name of our parameter in the form of string data, so we will put material in quotation marks. It then needs a parameter description variable to output the material parameter reference data into. So following that string data, we'll write the keyword out and then the name of our parameter description variable, which was param des. And now a reference to the material parameter is stored inside the parameter des variable. Now the whole point of using setParameterID was so that we don't have to access our parameter by its name. But as you can see, that's exactly what we're doing in the start function. Try not to let this confuse you too much, because we'll only ever be accessing the parameter by its name once, and that's at the beginning of our scene, using the start function on the first frame. Doing this once and then referencing that parameter by its ID for the rest of the scene whenever play run event is triggered is a lot more efficient than accessing it by name every time our player takes a step. So even though we still do need to access our parameter by its name at some point to get its ID, this still becomes more efficient because we're only doing it once, as opposed to multiple times during runtime. Okay, so we've nearly got our ID. All we need to do now to access it is to write the name of our parameter description variable followed by .id. In fact, that's what we can replace the name of our parameter with inside of our setParameterById function. So let's replace a material with param des.id. And that's because the ID variable of the parameter description struct is of the parameter ID data type, which is what our setParameterById function requires. And so now if we take a look at the setParameterById function, you can see that the error line that we were receiving earlier has gone. So with that, let's save our script with Control S or Command S, and let's give this new script a quick test. Now you may have done this already, but what I've quickly done in order for me to test my footsteps is I've quickly come over to this little broken bridge which you can find at the beginning of the first level, and I've made sure all of the game objects associated with it have been tagged with the stone tag, which you'll remember from our footsteps lessons was what we used to check the material our player was on top of. So I'm going to make my way over to this stone bridge and see if we can hear a change in the footstep material. Okay, so if I now walk along the grass, we should hear grass footsteps play. Brilliant. And now if I walk onto the stone bridge, we hear stone footsteps play, so it works. So our new function works, and now Unity can make less checks whenever our player takes a step. But we're not quite done with parameter IDs just yet. Obviously, if there is a parameter ID data type, then that must mean we can create a parameter ID variable. So if you wanted to, instead of feeding the parameter description variable into your function, you could declare a variable of the parameter ID data type. So for example, I'm going to quickly create one, which will look like this. fmod.studio.parameterID. I'm going to call mine paramID for short. And then inside of the start function, we can set it to our ID by writing its name. I'm writing equals param description.id. We can then feed this variable straight into the setParameterById function. So let's remove parameter description and add parameter ID. And so now we've improved our script and made it a little bit more efficient. But if you wanted to, you could actually discover what the ID of your parameter is, removing the need for some of these variables. To do that, simply start by creating a debug.log function inside of the start function. Now, as I mentioned earlier, a parameter's ID is broken up into two parts called data1 and data2. Now, as you can see here, both of these are variables of the uint data type that can be accessed through the parameter ID struct. What is a uint data type? Well, uint, short for unsigned integer, can only hold positive numbers, whereas a standard integer variable can hold negative numbers as well. That's really all we need to know about them, but if you do wish to learn more about the difference between the two types, you can find a very useful article about them under this lesson. So if we wish to learn what our parameter's ID actually is, we can feed those two variables into our debug.log function, which will display the values they contain inside of Unity's console tab. So inside of our debug.log function, let us write paramID.data1, separate data1 from data2 with a space, and then write paramID.data2. Now let's save our script and check it out in Unity. So once you start your game, you should see the two parts to your parameter's ID displayed in the console tab. Now that we know our ID, we can make our script a little bit cleaner. If we know the ID of the parameter we're after, then we don't need to access it by using a parameter description and event description variable. So what we're going to do is select our debug message and then highlight and copy data1 with Control C. Next, we're going to remove both the debug.log function and the line where we set parameter ID to our parameter description's ID variable, which are these two lines here. Then we'll replace it by setting the data1 variable from within our parameter ID variable to the value we just copied. So I'm going to write parameter ID dot data1 and then set that to the number I just copied, just like that. Then we can go back to our message and do the same for data2. Copy it and then add a new line and then set data2 to the value you just copied. There we go. And now that we've set data1 and data2 to the ID of our material parameter, we can remove our event description and our parameter description variables, as well as the two functions we used inside the start function to set them. So as you can see, this is a nice little option you have if you ever wish to learn what your parameter's ID actually is. Let's quickly save our script one final time and give our script another test. So once again, our footstep materials are changing correctly, meaning we've successfully given our script our material parameter's ID. And with that, you should now not only understand what a parameter ID is, but you can now also set values to your parameters by using their IDs. We've talked a little bit about how and when you might use the set parameter by ID function over set parameter by name, and we've also seen how we can discover what our parameter's ID actually is, as well as the different variable data types that can contain information about parameters. So I hope you've enjoyed this new lesson in Module 5. For the next lesson, we'll be introducing ourselves to a new type of parameter and learning about how it works and how we can interact with it through our code. So once you feel like you've got a good grip of IDs, head on over to that next lesson.